All right, good afternoon, folks. Thanks for taking the post-snack time to join today. My name is Keith Gilbert. I'm a security engineering manager across a couple of different services within the external security services. And we'll wait to see if he gets the volume up anymore. Is that better? Better? All right, cool. And also serving as a steering committee member for OCSF, which is the Open Cybersecurity Schema Framework. And that is what we are here to chat about today. All right, cool. Now we're good. So today we're going to talk about a handful of topics. This is the overall agenda here, but I think really what I want to take away from this at the end, you should have a very good intro on what OCSF is and what it is composed of, things it can help with, but also where to find more information. That's really my goal here today, is to get you what you need to know for an intro and then figure out where you need to go to learn more, participate, join, contribute. So I just want to kind of get a handle here first. Of the first 5 bullets here, how many folks in the audience have a role in one of these areas? So response, detections. All right, pretty good collection. Probably the more important question, prior to today, how many of you have heard of or know what OCSF is? So a good mix. Okay, cool. So hopefully it's helpful for you as well as others, and then we can get you pointed in the right direction. So the first items I want to go over is kind of give an idea of the problem statement, right, that we have. So what happens when your organization decides they want to trial a new security product? How long does that take? Is that a 30-day turnaround, 6-month turnaround? And what are the roadblocks in that? So a lot of the time, first question, what format's the data in? How am I going to get it? How do I integrate that in my current workflow? If the trial of that requires additional work outside of your normal day job, that's going to be a pain point in evaluating the effectiveness of that solution. Internally, your applications developed by your application teams, your security teams, do you have an internal standard that those teams are producing logging for you to enact security outcomes? Do you have something you can communicate that's documented to them that they can use in that development? Another common scenario, your organization acquires or is acquired by an organization. How much overlap is there between the security solutions in place in that organization or the security solutions in yours? And how long does it take to mirror those two? Can you immediately deploy your processes, your detections over the data that's originating from either end of that spectrum? Overall, what does that interoperability look like? How much value can you get immediately in that situation? And then what if your internal analytics teams want to develop detections, do data analysis? How much time are they spending organizing and structuring your security data in that scenario? So depending on the particular survey that you consult or the year it was done, the results range, but it's not insignificant in any case. So generally 30 to 80% of time from data scientists or data engineers that are surveyed are spent using or otherwise kind of organizing their data on site. So how do we make progress in any of those scenarios or others? And generally, our solution and what we're here to talk about today has been a standard. Now, I know one thing we get is why this standard over other standards? And there are a variety of reasons. So first and foremost, OCSF is designed, contributed to, maintained by analysts, folks that are doing the work. And so one of the items that we'll go over, there are several structures within the schema itself which are designed to help use cases that are common for security analysts. It's community driven, it's open, anybody can contribute, make suggestions, provide feedback. At this point, there's solid industry buy-in, so we have in the dozens plus of organizations which are actively either contributing or consuming OCSF, and from a membership perspective in the particular Slack that I'll also provide information on, there are folks from over 100 organizations present currently. And then one of the other main driving factors for OCSF that we wanted to ensure came through, and one of the reasons that we chose to work on OCSF instead of using a pre-existing solution at the time, was that we wanted to make sure that all of your logs maintained the accuracy and semantics present in the source logs themselves, which was a pain point that we'd seen in the past. So where else has using a standard to solve a problem worked? A couple of examples, different use cases. We have STIX, which many of you may know is useful in the cyber threat intel sharing realm. And then Verus, which is timely. The data breach investigations report for this year came out last week. That's been running for over a decade, and really that report is made possible by using a standard data model for all of the metrics that are used in that and analyzed in that report. So we're going to run through kind of a quick overview. As publicly announced last year at Black Hat, we had 18 organizations intimately involved in creating it at the time. As I mentioned, there are now 100 plus organizations that are in the public Slack workgroup. And we have calls weekly on various topics. And so I think right now we're running 3 calls a week for active development. Current status, and this, so RC2 was released in early of Q1 this year. The intent of that was really to get a lot of community feedback and determine, if there were any gaps that we had that needed to be filled prior to getting ready to go to a full version 1. Got a lot of feedback once that was released. Participation skyrocketed, and we just released RC3. The intent of this particular release is to convert to version 1. So absent any major catastrophic miss, which we don't believe there will be at this point, that will convert later this year, target Q3, to the official first stable version 1 release of the schema. So we're going to run through the various constructs. So the first we have categories. These categories are essentially organizational in nature. They allow you to group event classes, which we'll also talk about. Make it easier to find things when you're looking and learning about the schema itself. And then those event classes are basically the specific schemas for each particular type of log, which would be used to analyze any of the sources that you have themselves. So these are specific requirements, and we'll go through those. So within those event classes, you have objects, pretty kind of standard data structure. An object can have many attributes. Those can be nested. They can be additional objects. And within those, the attributes have a name, a value, and a verified data type. So that's one of the areas here that's super important. We want to make sure that everything is very well structured and validated, or can be validated in a programmatic way. We also have profiles, which allow you to add additional constructs to event classes, which may not be relevant for all logs of that particular event class. So there's some examples on the screen here. Some kind of devices that cross boundaries, right, may provide more information than strictly the communication information on a network level. Those can be added with particular event classes related to security data or related to a particular kind of host type. And then extensions, and these are really where the schema is extensible for custom use cases. So if there is an object, an attribute, which is very specific to your organization internally, or from a security vendor perspective, if it's only usable or useful for their particular product, you can use an extension to define additional requirements within a particular event class. And those are then usable and basically self-documented within the schema. We do hope that this is minimized to truly custom use cases, and anything that turns into a more generalized sense gets submitted to OCSF as a proposal and incorporated into the schema itself. So some examples, I mentioned at the beginning that this was created by analysts, and we have specific objects within the schema that are useful for analyst use cases. The first is observables. So within a well-documented schema, you have many types of indicators that may be in many different types of fields that maintain context. And if you're issuing a query, for instance, over those, and you have an overarching, very large scale, did I ever see this IP address or this domain across all of my logs within my environment, you don't necessarily in that query want to have to go to every specific sub-field where that particular value may be present. And that's entirely the intent of observables. Is so when you're creating the log entry, you can pull those fields out of the structured example into a much smaller indexing-friendly object for any of the observable types that are of interest. These also maintain the context of the field they came from by having the field name present. So you can get a result of every place it happened and immediately know if it was a sender, receiver, what the particular context for that match was. We also have enrichments, very common activity on any pipeline. These will be defined, so you may add geolocation for an IP address, a threat intel match for any type of indicator, et cetera. Those are present within the format. And then we also have an attack object. If there are particular types of logs, this shows up most often right now in a findings type event class, but we have folks that are exploring other use cases for attack and more recently defend as well. And so overall, how does it help us improve? So if you want to decide to try out new products, there's an acquisition that occurs, going back to the questions we had at the beginning. In the case where you've got a standard format from all of your vendors, your internal teams have a reference that they can use to implement, even if it is OCSF compliant and they've created an extension for specific internal data. You're now in a situation where any change in operation, applying a new alert, adopting a new tool, can all act with your current infrastructure. Some other analyst-specific use cases that get benefit, right? So cross-organizational historic search, I mentioned the observables object. This is one place that long-term we think we'll find folks have a lot of significant value, especially as adoption continues to increase. Reduce latency in operationalizing data. If you get a new source, if there's a new data internally, that's going to become much quicker. And then on the alerting, detection, engineering side of things, you can write one rule across all of your data sets rather than having to customize rules per source. That also enables sharing of those particular rules much more easily across organizations, where right now you can publish a rule, but if it's specific to the format that you're storing in and that differs from the format somebody else is storing in, you've got an issue where they have to be converted, and that can add additional overhead. So there are some resources of note. So the top one there is the schema browser. So there's an interactive browser that you can basically log on, go through, you can explore the classes. The screenshots that I had were actually from that browser. You can select the version you're looking at. So if somebody has implemented RC2 or RC3, you can choose between those and see what the representative fields and event classes would be. The GitHub here is an overall organization, and there are sub-repos, which are all detailed here. Also, very important, the other piece of the GitHub, there are instructions on joining the Slack. So if you would like to join, contribute, learn more, ask questions, determine if there's support for a particular vendor, et cetera, the Slack link and join is present on that GitHub repo.